Hi, it's Griffin again, and this is a little extra explanation on what GitHub is. So, to understand what GitHub is, though, you need some background on what Git is. So, Git is an open source program for managing programming projects. It stores version history, it allows for you to change and update any projects that you have, and everything is stored online, which is great in the digital age. It groups your files together. The groupings of these files are called repositories. For example, when you continue on in this course, you will have a robot code repository with all the code that runs on your robot. Some features of Git: it has commands. The key commands are git commit, which allows you to essentially take all of the local changes, all the stuff you've done to your code right now, store them in a grouping, and then put them in the history as one kind of edit. Then there's push, which allows you to take any local commits that you have, or those groupings of edits, and put them online. Then there's git fetch, which is important because it allows you to see if there's any stuff on your online repository that has changed from what you have locally on your computer. And then there's pull, which allows you to take any online changes and actually add them into the code that you currently have locally on your machine. Finally, there's merge. This one's a bit of an annoying one. Git merge is when the local commits that you have or local changes don't align with what's online. You might have had this before in a Google Doc. If you went online and made edits, then it's all confused, like, hey, which one's the version that you want? So git merge allows you to go through every single change and essentially decide whether you want to accept your local changes or accept the online incoming changes. There's one problem with all this. It's all very useful, but it all runs in the command line. So for the most part, if you want to run any of these commands, you're going to need to use your computer's PowerShell or console to navigate to the folder, then run these commands, type in any messages. It's a bit of a hassle. Some people like doing it this way. If you'd like doing it this way, feel free. But most people in FRC use the better alternative, which is GitHub. GitHub is based off of Git, as the name suggests, and it's a website and app for working with Git repositories. It makes everything a lot easier. Essentially how it works is you have an account, login, username, email, password, you know the drill, and it allows you to see any repositories that you have online altogether. And even better, you can see other users' repositories that they've published. You can also share any repositories you have with other people. For example, my robotics team shares its repository with all of our programmers so that they can all add and make changes and view it. Essentially, this makes GitHub the Google Drive of programming. Now, this shows the online interface for GitHub. You could see that when you're viewing somebody's repository, they have a username and then a repository. So if you look at their username, they might have multiple repositories, multiple groupings, files, multiple projects. You can also see their most recent changes. You see in this highlighted one where it says making changes, it's 19 commits. That's the history, all the changes you've made. You can look back at that history. It's all saved. You can download the code if you want to take it. Let's say it's an application you might want to use. You also have the opportunity to work with others. You can fork a repository, which means that you can take a copy of it and work on it yourself, and you can even take that worked on one yourself and offer the changes back to the creator. It's all very collaborative, easy to use, works very well. And here is the GitHub desktop app. So you download it in the download tutorial. This has a few key features. So the first key feature is the repository selector. You log in with that username and password, and it shows you all the repositories that you own and have access to, and also those that you've cloned or copied from the web. It has a list of changed files. You can easily view all of the stuff that you've changed in this active editing session. It also has a place for you to write those commit messages. It also allows you to add a description easily. And once you commit it, it commits just like a regular Git project. It saves it in that history. I know it highlighted, but there's a history tab in GitHub Desktop too, which allows you to go through and view all of those changes. Whenever you download it, you get the full history. Additionally, what I'd say is the most useful thing is that button that I've highlighted that says pull origin in this example. It works as a pull, push, and a fetch button. So that means that If you haven't checked online for updates recently, it'll show up as fetch. You click it, it checks the internet and shows you any of the stuff that has been updated since you last checked. It then turns into a pull button, which means that you can take all that stuff and download it locally. Finally, it also has a push button. If you have pulled and fetched and there aren't any changes, it allows you to take your changes and put them online. Having one button for this makes everything extremely easy compared to having to memorize all the console lines. It allows you to manage everything well. A lot of teams use it. I'd recommend you do the same for this course. That covers the basics about GitHub Desktop. There's more documentation of GitHub available online, and we are linking, since we went over it very briefly, the Git website so that you can look into that more. So now you know the basics of GitHub.